Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
So, Sami, this incident today.
Yeah, super. So today, to walk us through this, we have Dave Maltz, our Technical Fellow and Corporate Vice President of Azure Networking. Dave, welcome. Thank you very much for joining us. I was hoping we could kickstart it with, we spoke about it being an Azure Front Door issue. We also know that other services that were impacted that either sit behind or leverage Azure Front Door. I'm curious to know, do both internal and external customers and parties use Azure Front Door? Could you help me understand the role that AFD plays here?
Sure. Let me start by introducing a number of the services that were involved in this incident. The key one is Azure Front Door. So Azure Front Door is a globally distributed, highly scalable front door for services that run inside of Azure. It provides services like global load balancing, middle box services like flighting, authentication, routing content from wherever clients happen to be on the internet to the backend data centers that are best prepared to handle those requests. It also offers a full content distribution network set of services. Now, also involved, so to answer your question as to how Azure Front Door might have impacted customer services and some Microsoft services. So many customer services, including many of you who I'm afraid and must apologize for having impacted during this incident, would decide to put a service like Azure Front Door between your clients out on the internet and your services in the data center. Your reasons for doing that might be so that you can use Azure Front Door's defense mechanisms to protect your services inside the data center from whatever type of attack might be happening from malicious clients out on the internet. You might be putting your service behind Azure Front Door in order to obtain the benefits of those middle box services, its ability to proxy your origin services, fill in extra data, do flighting, do content redirection, certificate authentication, things like those. Azure Front Door is used by both many third-party customers, as well as many Microsoft, what we call first-party customers. Those are large services inside of Microsoft, like Azure Portal and parts of M365. We're also sitting behind the same Azure Front Door as our external customers are.
Got it. Dave, thank you very much. That's good to understand the different parties and services involved here. You mentioned some of the different types of attacks that AFD can help protect against. In our post-incident review for this incident, I know we mentioned a distributed denial of service attack, but that was just the trigger event, right? Am I right in understanding that really the bulk of the impact from this incident actually had nothing to do with the DDoS?
That's exactly right. To explain that, let me talk a little bit about some of the other services that were involved in this incident. One of them is our wide area network. So our wide area network is owned and operated by Microsoft. It connects all of our regions together. We operate in over 70 regions around the world to, as I say, connect the regions together and also connect out to the internet. We peer with large internet providers and small internet providers at literally thousands of locations all over the world. Another couple of services that are involved here is our DOS protection services. The reality is everything of value on the internet is being attacked regularly in a variety of ways. And so Microsoft has a full suite of defense options that we make available to our customers and that we use to protect our own first-party services as well. Those go everything from what we call our one-DOS services. They're designed to protect against volumetric attacks, basically brute force attacks at layer 3 or layer 4 of the OSI network stack. They're essentially trying to simply overwhelm either the network or the receiving service. We have the one-DOS defense suite of services to protect against those, all the way up to things like our web application firewalls, our WAF defenses, like the ones built into Azure Front Door and our application gateway, that are designed to protect against what are called layer 7 attacks. Those are attacks that are targeting specific weaknesses in an application service. For example, they might be trying to send in queries that are very expensive to answer. So in this particular incident, there was what was called a volumetric TCP SYN flood attack, which basically meant there was an attacker who was sending a large number of TCP SYN packets. These are very small packets that come at the start of every TCP connection in an attempt to essentially overwhelm a portion of the Microsoft infrastructure. As I mentioned before, everything of value on the internet is frequently under attack. And so our one-DOS defenses are very scalable and very battle-hardened. We receive over 1,700 attacks every day. We have successfully received and defeated some of the very largest attacks that have ever been recorded on the internet. And this particular day, June 30th, was no different in that we were receiving attacks. And in fact, actually, the attack had been mitigated by our one-DOS defenses. And essentially, none of our customers noticed it, like the vast majority of our customers don't notice any of those other attacks that frequently happen on our network.
Super Dave, I would like to zoom in on something. You mentioned it, and we touched on it in the PIR as well, which is when our DDoS protection mechanisms kick in. You said most customers won't skip a beat, no one notices, but in the PIR, we did mention it. So when the DDoS protection mechanisms are activated, what does customer impact look and feel like? Is there some, is there small, is there no impact at all? Can you help me understand that a little bit better?
That's great. So our DOS shields, our defense shields, have many different mechanisms that they use to mitigate attacks. One mechanism that they have to mitigate this volumetric TCP SYN flood attack is what's called a SYN auth challenge or a SYN cookie. These are very well-known defense mechanisms in the industry. I think SYN cookies have been around since the mid-90s. In a SYN cookie defense, as a SYN packet comes in, basically indicating some client wants to start a new TCP connection, the defense mechanisms are going to send a SYN ACK packet. They're going to send a packet back that contains essentially a challenge in it saying, are you really a real client who's actually trying to open a connection, or are you just some brute force robot that's sending lots of SYN packets and not actually processing or caring about them at all? Some clients, when they receive a SYN auth, don't retry properly. They don't have the right logic for handling that. And so when we're using this SYN auth defense, clients without retry logic in them can see a longer delay or a longer period of time before actually eventually retrying and then getting a successful connection.
That's helpful to understand what this would have felt like for customers there. So, but beyond that initial trigger event that we've touched on, reading the PIR, there were really two main kind of problems that happened here. One was a control plane failure, and then one was a network misconfiguration. So I want to ask you about each of these. Well, on the control plane side of things, we were talking about our control plane, not customers' control planes. And what couldn't we do that we were trying to do, Dave?
Okay, great. Part of our defense shields involves hardware scrubbers. These are physical devices located all around the world that we can, when we're under attack, send packets towards because they have specialized hardware on them that's optimized for processing DOS attacks, separating out the wheat from the chaff, if you will, letting good packets through and then dropping packets that are malicious or are part of some kind of traffic abnormality that we want to remove from the incoming stream. Now, to tell those hardware scrubbers what traffic we want them to scrub and what traffic they should let pass through normally, we have an entire control plane that decides when the hardware scrubbers are needed and when they're not, placing them in and out of service. Now, during the DOS attack that was successfully mitigated, our control plane put the hardware scrubbers into service. And as I mentioned, they successfully scrubbed that DOS attack so that it had no effect on our customers. But then the challenge came when our control plane detected the DOS attack had ended and went to remove the hardware scrubbers, basically telling them that they could stand down now. They were no longer needed. The commands that they sent out to take the hardware scrubbers out of line, out of service, were successfully processed by all the hardware scrubbers except for one device located in the European geography. That device remained in service because it did not receive the messages from the control plane telling it that it was okay to stand down. Now, we're still in the process of doing the deep investigation to figure out exactly why this one hardware device remained in service, even while all of its other peers did properly take themselves out of service. There are a number of factors that went into that. We're trying to tease those factors apart. There was a local power failure in the facility where that hardware scrubber was located. However, our control plane also has multiple retry and multiple connection mechanisms available to it. And so we're still trying to get to the bottom of why this one scrubber remained in service even after the control plane told it to stand down.
That's fascinating. Thanks, Dave. And then separate to that, we had a configuration issue. And this meant that, and I want to understand if this was separate to the control plane issue, but then we had traffic from across Europe and maybe broader, I'm not sure, but all of that was being converged into that one site that was still advertising itself, or it was still activated. Could you double click on that a little bit more?
Certainly. So as I mentioned, Microsoft owns and operates our own wide area network that connects all of our regions together and connects clients out to the internet. Now, the job of that WAN is to provide connectivity, but it also has a bunch of safety protections built into it. So there are policies configured onto the routers that make up the WAN that are designed to keep a problem in one geography from spreading to other geographies. So that normally, for instance, when one hardware scrubber, stays in service and continues to ask for traffic to be sent to it to be scrubbed, even when we've told it to remove itself and stand down, those policies that break up the geographies in our WAN are designed and built so that those messages don't extend beyond the one geography where that scrubber is and essentially contain all the problems to the one geography. We are always in the process of updating our WAN, and we are currently in the process of rolling out a new class of routers that has higher speed and newer functionality. As part of configuring that new set of devices, one very important configuration clause was missed, and it was the clause that implemented those blast walls to constrain problems to a single geography when related to these specific hardware scrubbers. So what that meant is that when this one hardware scrubber in Europe continued to attract traffic, even after being told to stand down, those messages to attract traffic were actually distributed more broadly outside the European geography and caused some locations in other places around the world to send traffic towards Europe, where it was actually handled successfully by that hardware scrubber, but then given to Azure Front Door machines just in that Europe location, which then didn't have enough resources to handle all the requests flowing through it, resulting in the congestion and impact that seriously impacted our customers from around that 11:45 UTC up until around 1300 UTC.
Okay, thank you, Dave. So it's good to understand now we've got those three separate issues, clear in our minds. We've got the initial trigger event, we've got the control plane failure, and then we've got this last misconfiguration that routed too much stuff towards the Europe area. So that's now that we understand all the different areas that went wrong, what did we do? How did we respond to that? I understand you were on call. You and I both worked on call during this incident. So what did we do? How did our people and systems respond? How did we detect what was happening? How did we investigate it? And ultimately, how did we mitigate the pain for our customers?
Sure. So very soon after the impact started, Microsoft Outside-In Monitoring detected that key Microsoft first-party services like our Azure portal were not at 100% availability from all locations around the world. Many locations did continue to see 100% availability because, as I mentioned, the messages' greatest impact was in European regions, and messages did expand out to some other geographies. Once we saw this drop in availability, engineers from the Azure Portal team engaged, very quickly realizing they needed help from the Azure Networking and Azure Front Door teams. Engineers from my team engaged, began looking at what was going on. The one thing that we saw very quickly was that there were some Azure Front Door servers that were in a very high resource utilization situation and might be dropping packets. Not yet knowing exactly what was going on or all the steps involved, we then took a mitigation activity, which was saying, all right, let's put all of our hardware scrubbers back in service to take whatever traffic is coming in, spread it out across the entire fleet, and maximize our ability to handle all of that traffic. It turns out that was exactly the right decision to make, and that then mitigated the vast majority of impact for the vast majority of our customers. What we were left with then is this residual impact, basically because our hardware scrubbers were still engaged, still applying that SynAuth challenge. Applications that didn't have the appropriate client retry logic would see either timeouts or longer latency for each of the connections that they were making. That then persisted for some number of hours. And I again apologize If you had an application that was impacted during that residual impact time period, we were just being conservative and very careful to make sure that we understood exactly what was going on, what had happened, before then moving away from that essentially full hardware scrubber in service. Once we had a better understanding of what exactly had happened, we then very cautiously went through the stages of turning off our global DDoS mitigation, telling all those hardware scrubbers to stand down, being extra careful to make sure that that one misbehaving hardware scrubber did the appropriate things this time around.
Magic, super. Thank you very much, Dave. Under the idea that we never let a good incident go to waste, and we're continuously learning from events like these, what are the things that we're learning and what are we doing to kind of protect this type of thing from happening again?
Great questions. So some of the things were immediately fixed. So for example, the missing configuration was immediately rolled out to all of our wide area networks. Well, when I say immediately, we have a safe deployment principles that we use. So we tested it carefully. We rolled it out to our first ring of routers, but then with great expediency, rolled it out to all of the routers that needed that configuration. So again, we are now back in the well-protected state where even if there is a problem in one geography, it'll be contained to that geography, not spread to other portions of the world. Another thing, though, that we learned from this is that we need to be continuously testing that these isolation policies, these blast walls, if you will call them that, are always correctly operating. And so we're standing up a set of runners that'll be continuously probing to make sure that information is being propagated across the network in the way we expect. It's being allowed where it should be allowed and blocked where it should be blocked. So that's another one of the things that we're doing, again, to ensure that regardless of what kind of routers we add or what other policies we add to the network over time, that we always maintain those geographic isolation principles. The final thing that we're doing is we are working to improve the monitoring of our basically how all the systems, Azure Front Door, the DDoS Shield, work together so that we have very clear indications of exactly what's going on so that our time to mitigate will be much faster if there is ever some kind of issue again in the future.
That's helpful to understand, Dave. I'm glad that we've got some learnings and some repair items that came off the back of this. I wanted to ask you, this is the last question I had on the list here. You know, what should customers learn from this? Obviously, we don't want to be opportunistic, but building reliable apps on Azure is a shared responsibility. Is there any kind of best practices or recommendations for customers to improve their own systems?
Okay, one thing I would, of course, suggest is that reading up on particularly DOS in general, and then the DOS defense mechanisms that Azure has available is a great thing to do. There are links in the PIR we sent out to how the various DOS shields that Microsoft offers work. Make sure that you're behind the right set of shields, that you've got the right policies that you want for protecting your applications and your services. That's great background knowledge. Another takeaway from this and other incidents is the importance of retry logic. We have seen incidents that have actually been made worse, or customers have experienced greater impact because their retries were too aggressive. We've also seen, as in this case, that not having an application retry logic does mean that whenever there's any problem downstream, whether it's in your origin server and any of the infrastructure between your origin server and your client, or even in other layers of your client, like the web browser or the operating system, without having, if there isn't appropriate retry logic in your application, that's just going to delay the length of time that your users are going to be sitting there waiting for a reconnect or for the information that they've requested to be presented to them.
Magic, thank you very much, Dave. And I know a lot of that information can be found on the Azure Well-Architected Framework for customers who are looking to how to implement a bunch of this. Typically, at this point in time, during these live streams, David will turn to me and ask me, how do we do in comms? But seeing as David was on call and David was the one who was managing comms in this incident, I get the pleasure of saying, David, how did we do today in comms?
Very good. Like Sammy often says, we've got good news and bad news, right? Our comms for this, we were quick. The most important thing is we got our initial comms in terms of lighting up the status page to say we were aware of something, initially just a portal issue. We're aware of something, we're looking into it. We got that up within 5 or 10 minutes of the impact, so that was good to detect it quickly. But that's up on the status page, and so what a lot of customers really need is the in-portal, the targeted communications that are wired up through Azure Service Health Alerts to go and notify their own problem management systems or to involve their own on-call folks. Those targeted communications did take time. It was a few hours before we were able to start getting out, hey, here are the specific Azure Front Door customers that were impacted. We were able to get that out for app services and application insights and policy and some of the downstream services that were impacted by this incident. But one of the big oversights we had was Azure Portal users themselves. I was talking to our Azure Portal on-call team during the incident, saying, how can we narrow down which customers are impacted? Just because of the way that Azure Front Door is structured and because of the way the portal uses it here, we weren't able to narrow down exactly which portal users were impacted by this. Right? If you're a user, you're trying to load some web resource, it wasn't clear whether you're related to 0 subscriptions or 1 subscription or 100 subscriptions. So narrowing that down was difficult and was actually impossible. We weren't able to narrow that down. And this was about 20 minutes away from mitigation. And ultimately, we didn't send an in-portal communication for those portal users. I think with hindsight, that was the wrong decision. If our options are all or nothing, we actually should have sent those targeted communications to all of the millions of portal users just to make sure that they were aware of it. So I think that's a learning for next time, is making sure that if we're not able to target it, if we're not able to narrow down those comms, we should be sending something anyway, even if it's over communication, even if we're sending it to customers who actually weren't impacted by the issue. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage, and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.